Welcome to the Rosny College Electronics series of videos. This video I'm going to be looking at how to use Ohm's law to calculate either a voltage, a current or a resistance. Say for example we had a battery just connected with a simple resistor, and for realism's sake I'm going to use a simple circuit based on some real values that we're actually going to measure. So last video I looked at how to measure using the multimeter. So what I'm going to do is I'm going to measure the voltage and the current and the resistance in different parts of the circuit, then compare to see how they compare using Ohm's law. So firstly I'm going to measure the voltage across my resistor. So I put it on, it's a 9 volt battery, so I'm not going to expect any more than 20 volts. And I can see that I've got the probes on back to front, so we've only got 7.7. Oh, it seems to be running the battery flat. I'll hurry up. We get it on 7.70. Disconnect it. 7.70 volts. And now I'm going to measure the current. So I'm not expecting it to be larger than 20 milliamps. So do that all together. 16.55. Don't forget to put my units in. Okay, so I'm not entirely sure how well this is going to go because I have a sneaking suspicion that the battery is starting to drain too much with this small resistance. But we will still be able to be relatively close, and I'd expect that just going to take the battery away. I'd expect that the resistance is going to be within reasonably close to what we would measure. Okay, so Ohm's law states that V equals I times R. So sometimes you see just IR, sometimes you see a little dot between it, or sometimes you see a multiply, so I times R. I'm just going to use this notation to start with, IR. So R equals something, so I'm going to have to transpose this equation. So if I've got I times R, or R times I, which both works, then so I've got I lots of R, but if I only want one lot of R I need to divide by I. So I need to divide both sides by I to keep the equality, so it's going to be V divided by I. Okay, so I've got my measured voltage, 7.70 volts, divided by 16.55 milliamps. I need to put that into into amps, sorry. So that is 0.01655, because 1 milliamp is 1/1000th of an amp, or in other words, 1 amp is 1000 milliamps. So I would have 16.55 1/1000th of an amp, which is 0.01655. The easy way to do that is simply move the decimal point 3 places. So that's where the decimal point was, so I've now moved it 1, 2, 3 places. So I've now got my formula here, R equals V divided by I, which is 7.7 volts divided by 0.01655 amps. Now I'm going to switch to my calculator here. Do that. 7.70 divided by 0.01655 equals 465. I'm just going to round it to the nearest whole ohm. Okay, so 465.2 or 0.25 is closer to 465 than 466, so I'm going to leave it at 465 ohms. So I've got 465 ohms as my calculated resistance, and now we're going to put my meter onto the ohms. I'm going to set it to 2000 ohms because I know it's not going to be larger than that, and 464 ohms. So 464 ohms was measured, and 465 ohms calculated. Now, because the multimeter, the internal workings of the multimeter, is actually doing exactly this calculation for us, we would expect them to be exact. However, like I said, the battery I think is on its way out, and so the current may have been either more or less than it was for this reading of 7.70 volts. So that's probably the source of the difference between these two values. So if I know the voltage, the resistance, I can calculate the current. If I know, well really, if I know any two of these three things, I can calculate the third. So a good way that I've seen this is the triangle to help you transpose. So the way this triangle works is that if I want to find one of the variables, so let's say I want to find R like we did in this previous example, then you put your finger over that and the relationship is given, so the V is over I, like it was here, V over I. If I want to find V, then it's I times R, which is what we have up here. Okay, and likewise if I want to find I, then the relationship is going to be V divided by R. So I equals V over R. So those are the ways that we can use Ohm's law. If I have another circuit where I know the resistance and I know the voltage, I can calculate the current. Now this is quite valuable because if you recall, in order to measure the current in our circuit, we needed to break the circuit and insert our multimeter. That's not always possible, especially for circuits that have been built. It's a bit difficult to breaking the circuit and adding your multimeter in just to measure, see if the current's okay. So quite often what you do is you have a known resistance and you measure the voltage across it. So let's just use the same values that we got here because we know that they're roughly right, and see if we can calculate the voltage, the current through it. So if we have R equals 465 ohms, because that was our measured resistance, and we measured 7.70 volts across it, then I, which is equal to V divided by R, equals 7.70 divided by 465 equals, go back to my calculator, 7.70 divided by 465 equals 0.016. I'm going to go 6 there because 1655 is closer to 166 than it is 165. Okay, so I've rounded it to the three significant figures there, and that's in amps. Okay, so we've got 0.0166 amps. Now to convert that to milliamps, all I need to do is move the decimal point 3 places to the right now, equals 16.6 milliamps. So this is a common technique for finding the current in a circuit without actually having to measure the current directly. You can measure it based on the known resistance and the voltage.